Number 6 gives us the graph of the derivative and then asks us to locate and classify extrema of f of x. Extrema occur when the first derivative changes sign. This is a graph of the first derivative, so we want the sign of this graph to change. So this graph is positive, not the slope of the graph, but the graph itself is positive right here. It's above the x-axis. Now it's 0, so that's a critical value at -2, but the graph stays above the x-axis. It did not change sign, so -2 is neither a min nor a max. Over here at x equals 3, the graph was positive, and then it changed to negative. It went from above the x-axis to below the x-axis, which gives us a maximum value. If the derivative is positive going up and then negative going down, that's max. So we have a maximum at x equals 3. Part B wants us to write an equation for the line tangent to f of x at x equals 2. We need a point at x equals 2. We have that point right here. So my point is 2, -7. And we need a slope. So we need to know what f prime of 2 is equal to. This is a graph of f prime. So this graph evaluated at 2 is 16. That's our slope. Y equals 16x minus 39. Part C asks when f of x is concave down. Concave down means the second derivative is negative. The second derivative would be the first derivative of the graph that's given. So I'm looking for when the slope of this graph is negative, which is -infinity until -2, and 1 to infinity. -infinity to -2, and 1 to infinity. And finally, part D, sketch a possible graph for f of x. So this graph, which is our derivative, is positive until here. So my slope needs to be positive until -2. Positive until -2. And now it's 0. But then it stays positive until 3. So my slope stays positive until x equals 3. And now the slope is negative. And we have that relative maximum at x equals 3.